Today we are going to discuss chapter 3. This chapter deals with ionic and covalent compound. In this chapter we will learn about what is a chemical bond, and in this section we will learn about two kinds of bonding. First is ionic bonding and then the other one is covalent bonding. So in today's lecture I will focus only on ionic bonding. So in ionic bonding, all compounds which have ionic bonds, they are called ionic compounds. Now there are two kinds of ionic compounds. First one is ionic compounds which contain monoatomic ions, and the second one is those compounds which contain polyatomic ions. So we will discuss in detail about these two kinds in next slides. In previous chapter we learned about atoms and atomic structure. We learned that atoms are made up of electrons, protons, and neutrons. We also learned about periodic table, and we found that there are about 118 different kind of elements. Now among those 118 different kind of elements, there's a one unique group of elements called noble gases. Now what's special about noble gases is that they are extremely stable. Noble gas atoms do not react with any other atoms. However, this is not the case for rest of the elements. The atoms from rest of the periodic table are not that stable. In order to achieve stability, they want to be like noble gases. So how do they want to be like noble gases? They want to have their electronic configuration similar to noble gases. Now we learned that noble gases have 8 electrons in their valence shell. For example, if I let's take an example of neon. So neon has 10 electrons. Okay, so its electronic configuration is 1s2, 2s2, and 2p6. So its valence shell is second shell. So in second shell there are 2 plus 6, 8 electrons. All other elements, they want to be like noble gas, so they will either lose, gain, or share electrons. When they lose, gain, or share electrons with some other element, they form a bond. Now bonding is the joining of two atoms in a stable arrangement. Now when a chemical bond is formed between two or more atoms, a complex aggregate is formed, and that aggregate is known as compound. In this picture is showing you an example of a compound caffeine, which is found in coffee or tea. Caffeine is made up of carbon, nitrogen, oxygen, and hydrogen atoms. All these atoms are sharing their electrons. We will learn about how the sharing takes place later on, but for now you can see that they share their electrons, and this model, these sticks in this model, so these sticks represents a bond. There are two different kinds of chemical bonding. In first kind, there is a complete transfer of electrons between two atoms belonging to two different elements. In this process, one atom will lose an electron and the other atom will gain an electron. The compound which is formed as a result is known as an ionic compound. One of the famous or most common example of this kind of ionic compound is sodium chloride, which is table salt. In sodium chloride, sodium metal loses an electron, and that electron is gained by chlorine atom. The second kind of chemical bond is called covalent bond. In covalent bond, atoms do not lose or gain electron. Instead, they share electrons. For example, atoms of chlorine gas, they share their electrons in this formation, and as a result a chemical bond is formed, and this bond is known as covalent bond. Let's discuss ionic bonding in detail. Ionic bonds are formed between metals and nonmetals. Metals are found on the left side of periodic table and nonmetals are found on the right side of periodic table. When metals and nonmetals react with each other, electrons are transferred from metal atoms to the nonmetal. So imagine this is an atom belonging to a metal, and this one is a non-metal. So when they react, electrons will be transferred from metal to non-metal. So metal atom will lose an electron and non-metal atom will gain an electron. Let's see what happens afterwards. Let's take an example of sodium atom. So sodium is a metal. It has 11 protons in its nucleus and 11 electrons in its around the nucleus. We know that protons are positively charged and electrons are negatively charged. Now, because total number of positive charges and total number of negative charges are equal, therefore sodium atom is neutral. So it has no charge as such. If we write its electronic configuration, we will get 1s2, 2s2, 2p6, and 3s1. We know that the last shell is called valence shell, and on this valence shell, which is the third shell, there is only one electron. We previously learned that atoms would like to have 8 electrons to be stable. So in order to be stable, either sodium can gain 7 more, which is not possible, or it can get rid of this one extra electron on the third shell. If it gets rid of this third shell electron, it completely gets rid of that third shell. So now the valence shell is the second shell. So on this second shell, we can count that there are total 8 electrons, which is now the stable arrangement. So let's recap. So in order to be stable, sodium atom loses an electron. Now when it loses an electron, sodium now has only 10 leftover electrons, but nothing changes in terms of protons. So it still has 11 protons. It means there are still 11 positive charges, but because we lost one electron, so now there are only 10 negative charges. So because of there is mismatch of total number of positives and negatives, so this makes sodium atom not neutral anymore. In fact, in this case, the total charge is 1 positive. We can calculate the charge by subtracting the number of electrons from number of protons. So whenever an atom gets a charge, it is known as ion. So after sodium loses an electron, it becomes sodium. So this is sodium ion. So because now there is a charge. So ions are either positively charged or negatively charged. So if an ion is positive charged, that kind of ion is known as cation. So cations are positive charged ions. So we can say that sodium ion is a cation. Now in this particular case, sodium metal lost 1 electron because that would give it stability. Other metals may lose 2 or more electrons in order to be stable. If a metal loses 2 electrons, then the charge on that metal ion will be 2 positive. If a metal loses 3 electrons, then the charge will be 3 positive. Nonmetals, on the other hand, would like to gain electrons to achieve stability. Let's take an example of chlorine atom. So in this case, chlorine atom has 17 protons in its nucleus, and around the nucleus there are 17 electrons, which makes this atom neutral because total number of protons is same as total number of electrons. If we write its electronic configuration, we get 1s2, 2s2, 2p6, and 3s2, 3p5. Again, in this case, the valence shell is the third shell. If we count total number of electrons on this valence shell, we see that there are 7 electrons in the outermost shell. In order to achieve stability, atoms would like to have 8. So chlorine is just one more electron away from achieving the stability. So the easiest way to achieve stability is by gaining one more electron somehow. Okay, so what chlorine does is it gains one electron. Now, how do it gain? It gains electron from neighboring atom. That neighboring atom could be sodium, because sodium wants to lose electron, right? So that extra electron may be gained by uh, chlorine. So once chlorine gains the electron, so now let's look at its new electronic configuration. So the new electronic configuration, we can see that in the valence shell there are total 8 valence electrons, which gives it stability. Now, because chlorine has gained one electron, so after gaining, total number of electrons are 18. So now we have 18 negative charges, but nothing uh, changes, nothing change in number of protons. We still have 17 positive or 17 protons. So if we subtract the total number of protons and total number of electrons, we get the final answer as -1. So the charge on chlorine ion is -1. So negatively charged ions are known as anions. So anions are negatively or negative ions. So chlorine ion is anion. If we look at the transfer of electron process together, we will see that the sodium metal loses an electron, and that electron is transferred to the chlorine atom. So after the loss, sodium becomes positively charged ion or sodium cation, and chlorine becomes a negatively charged ion or an anion. We know that opposite charges attract each other because of electrostatic interaction, and that electrostatic interaction is responsible for the formation of ionic bond. The compound which is formed as a result is known as ionic compound. So we can say that ionic compounds consist of oppositely charged ions which have a strong electrostatic interaction for each other, and the net charge in any ionic compound is always 0. The physical and chemical properties of any ionic compound is quite different from the parent metal and non-metals. For example, in case of sodium chloride, as shown in the picture, it is formed when sodium metal reacts with chlorine gas. Now, sodium metal is highly reactive metal, and it catches fire when it comes in contact with the water or moisture. It's quite dangerous. Similarly, chlorine gas is a yellow gas. It is also quite toxic and is harmful if inhaled. However, when they combine with each other, they form sodium chloride, and sodium chloride is an essential nutrient. We need it for performing many bodily functions. So you can see that the properties of sodium chloride is nowhere close to the parent sodium metal and chlorine gas. Another example is hydrogen and oxygen. Hydrogen is extremely flammable gas. It catches fire and it has extremely high calorific value. Oxygen is also an essential gas for combustion. In fact, it promotes combustion, but when they combine, they give rise to water. And we all know what water does to fire. It puts it off. So properties of the product is always different from the parent elements. So let's recap. So ions are formed because atoms want to be stable, and in order to be stable, they need to have 8 electrons in the valence electron, and this is known as octet rule. So octet rule is that all main group elements are stable when they possess 8 electron or octet of electrons in its outermost shell. For example, sodium, we already saw that it has only 3 valence electrons as shown here, and once it loses that third shell, now it has octet of electrons in the second shell, which is similar to the neighboring noble gas neon. And that's why now, because the electronic configuration is similar, therefore sodium ion is stable. Similarly, when we have a nonmetal, fluorine in this example, we can see that in its valence shell it has 7 valence electron, and when it gains 1 electron, so 1 electron is gained here. Now it has octet completed, and its electronic configuration is similar to the neighboring noble gas neon. That's why fluoride ion is stable. So this is known as octet rule. So far, we have learned that ionic compounds are formed when metals lose electrons and nonmetals gain electrons in order to achieve stability. This stability is achieved because after losing or gaining electrons, metals and nonmetals achieve fully completed valence shell, or they have 8 electrons or octet of electrons in their valence shell, which makes them stable. Now, many of us might be wondering that how do we know that how many electrons a metal it needs to lose, or how many electrons a non-metal needs to gain? Simple answer is that you can figure that out by writing electronic configuration, but there is another shortcut method. So in this shortcut method, all you need to do is look at the periodic table. In your periodic table, you will see on top of groups, you will see numbers and letters. For example, here is 1A, first group is called 1A, and then this is 2A, 3A, 4A, and so on. These A kind of groups, or these elements, first two groups and then remaining these groups, these are called main group elements. Okay, so main group element. Now, if your metal belongs to main group element, it will lose same number of electron as the number of that group. For example, first group, lithium, it's in the first 1A group, it will lose 1 electron. If it loses 1 electron, the charge will be 1 positive. If your metal is in 2A group, it will lose 2 electrons. So its charge will be 2 positive. If your metal, for example, aluminum here, let me erase this line, okay. If your metal is in 3A, that's why it's gonna lose 3 electrons, therefore the charge on aluminum ion is 3 plus. So that's the case of metals. There are a couple of exceptions which we will discuss later on. Now let's talk about nonmetals. Now nonmetals will gain enough electrons to be like noble gas. Now noble gas is in group A, so how many electrons non-metal is gonna lose? All you need to do is subtract their group number from the number 8. If your non-metal is in 7A, then subtract 7 from 8, so it means 1. So it means these non-metals gonna gain 1 electron. Oxygen is in 6A group, so you subtract 6 from 8, so therefore oxygen gonna gain 2 electrons, and so on. So that's one way of figuring out how many electrons a metal is gonna lose and how many electrons any non-metal is gonna gain. The ions from main group element are known as fixed charge ions. For example, metals from group 1A or 2A or 3A are called fixed charge cations. Why they are called fixed charge? Because they will always have same charge. So sodium metal will always have 1 positive because it belongs to 1A group. Aluminum because aluminum is in 3A group, so it will always have 3 positive charge. That's why all these metals are fixed charge metals. Similarly, non-metals, 6A, 7A, are called fixed charge because they will always have same charge with no exception. Transition metals, on the other hand, are called variable charge metals. Now, transition metals are found in the middle of the periodic table, so these are called transition metals, and their group numbers will have a letter B on top. So these are variable charge metals. So metals belonging in this category will have different kind of charges depending on the condition. They don't really follow octet rule, so we can't really figure out how many electrons these metals gonna lose. Definitely they're gonna lose the electrons, but we don't know how many electrons they will lose. Therefore, by just looking at that atom, you cannot predict whether it's gonna have a 2 positive charge or 3 positive. Some of these may have 4 positive also. There are couple of exceptions in transition metals. That exception is zinc, silver, and cadmium. So these three are exceptions, which means that zinc will always lose 2 electrons, so it will always have +2 charge. Cadmium also will be +2, and silver always have +1. So even though they are transition metals, they behave like main group metal ions. Therefore, these 3 metals, they are included in fixed charge metals, which was the category we discussed in previous slide. Similarly, there are 2 exceptions in main group, and those exceptions are tin and lead. Even though tin and lead, they belong to main group, see the type A, main group, but they behave like transition metals. So in some cases, tin SN might be 2 positive, and in some other examples, tin may lose +4, and lead is also the similar case. So even though tin and lead are type A or main group metals, they behave like transition metals, so therefore they are included in variable charge metals. To recap, metal ions with variable charge do not follow octet rule. They do not lose all their valence electrons, and you cannot predict their charge by looking at their position in periodic table. In case of metal ions with variable charge, Roman numeral in parentheses is used to represent what is the charge on that particular ion. For example, if we have iron 2 positive, in the name we will write iron followed by Roman numeral 2 in parentheses. Similarly, iron 3 positive is represented by iron with Roman numeral 3 in the name. Keep in mind, these Roman numerals are only used if the metal ion is variable charge. It is not used for fixed charge variable ions. For example, silver ion, even though silver is a transition metal, but we learned that it is not a variable charge metal ion. Therefore, we do not use Roman numerals in the name of silver ion. Silver 1 plus is simply called silver ion. Similarly, zinc 2 plus is simply called zinc ion.